Hello. In the previous series, we derived the regression line with the help of linear algebra. This method enabled us to find the coefficients of more than one variable, unlike the method we used previously whilst deriving the regression line for a single variable in the deriving R square series. This type of regression, wherein more than one variable is involved, is called multiple linear regression. In this series, we are going to implement a code from scratch that finds the best regression line for a data set. Our first agenda is to have a look at the data we are going to deal with. Over here, as you can see, I have gone to this website called Kaggle. Some of you may already be familiar with it. Kaggle has many free data sets that can be used. So, this one that we are using today is called Housing Price Prediction. And as the name suggests, this data set can be used to predict the price of a house based on various features, which we'll call variables. This is pretty similar to the example discussed in the linear regression, a linear algebra perspective series. Okay, so now let us explore the available variables. The first one is price. This is our predictant, that is, the variable whose values we are trying to predict. The rest of the variables will be called predictors because they are helping with predicting the price value or the predictance value. You will observe that the variables area, bedrooms, bathrooms, stories, and parking are all numerical variables, whereas the others, that is, main road, guest room, basement, hot water heating, air conditioning, pref area, and furnishing status, are non numerical in nature. In fact, they can be assigned a value only from a finite set or only from a finite number of categories. Like if you see basement could be yes or no. So it can only be assigned one of these two values and nothing else. These kinds of variables are called categorical variables. We haven't dealt with them before, and hence I'm going to dedicate the rest of this video to introducing the concept of categorical variables and how they can be manipulated to be later used in the finding of the regression line. To discuss categorical variables, we'll use the variable furnishing status from the house price prediction dataset as our example. It has three possible values, which are fully furnished, semi furnished, and unfurnished. The problem lies here. All these categories are words, and linear algebra does not deal with words, or for that matter, even letters. So we need to somehow represent each category with numbers. But how should we do that? A naive assumption could be to assign 1 to fully furnished, 2 to semi furnished, and 3 to unfurnished. Now take a pause, okay, and think, is there any problem that could be faced with this representation? When we assign the numbers 1, 2, and 3, we are basically saying that semi furnished is equally far away from fully furnished and unfurnished. Reason being that we've assigned it the number 2, and the number numerically 2 is equally distant from 1 and 3, right? Or, another way of looking at this would be that unfurnished is 2 times the distance away from fully furnished as it is from semi furnished. Now, that thought may not always prove to be correct. So, let's explore this, okay? Let's say we quantified the different furnishing statuses based on the number of pieces of furniture. Each house that is semi furnished, do you think in real life would have the same number of pieces of furniture every single house? And even let's say by any chance they do have the same number of pieces of furniture, is it necessary that all these houses will have the exact same kind of furniture also? Not really, right? So then what ends up happening is each of these semi furnished houses are different and hence are at different distances from an unfurnished house which has zero pieces of furniture, therefore contradicting the fact that all these houses are from the same category, right? Now that creates an issue. Hence, you see, we enter a very complex situation when we start quantifying these categorical variables. Therefore, this assignment of 1, 2, and 3 would just end up being illogical because categorical variables are not quantifiable. Similarly, let's say you had a categorical variable called street number the house is on. So, like houses are on second street, third street, and so on. Technically, the values would have been numerical, but there are yet only a finite set of values that the variable can be assigned. So it would still be illogical to continue to use numbers to represent them. Okay, so now that we've discussed all of this, we still come back to the same question. What should we do? How do we deal with these categorical variables so as to use them in linear algebra? One solution is to create separate features or columns or variables, whatever you want to call them, for every single category. After creating the columns, if a certain category represents the data point, or in our case, that would be a house, then that column would be assigned the value 1, while the others would be assigned the value 0. For instance, here, house 1 is unfurnished, house 2 and 4 are fully furnished, and house 3 is semi furnished. This can be edited into the new format. You'll observe here that, for instance, because house 1 was unfurnished, the unfurnished column is assigned the value 1, while the other two columns are assigned the value 0. So now, I have another question for you. Do you think this representation could be made any more efficient? Maybe by deleting a column? The answer is yes. Any one of the category columns can be deleted. We will delete the semi furnished column, but you are free to delete any of these three columns. The reason why this would work is that if both unfurnished and fully furnished are assigned 0, as they've been assigned for house 3, it automatically means that house 3 is semi furnished, as that's the only remaining category. This works under the assumption that each house is 100% assigned one of the three category values, or in other cases, how many ever category values have been given for that variable. Along with that, no value should be null. Okay, now there's one more thing to note over here, that if a variable has only two categories, like basement could be assigned a yes or a no, then in these sorts of cases, you do not have to go through the entire process of creating new columns. You can skip to the end and just directly assign zeros and ones to each value. For instance, over here in basement, yes could be assigned the value 1 and no 0. Okay, that's it for today's video. In the next video, we'll start working on more technical parts of the code. Okay, see you then. Bye bye.